Today we're going to fill in notes number 25, translating problems into equations. So when you have a word problem, it's helpful to have a method to solving it algebraically and not just using arithmetic. So we came up with this little system to set up a word problem in the form of an algebra equation and solve it. So we just call it VUAS, and the V stands for variable. So the first thing you want to do is you want to define a variable. And the variable is going to represent what it is that the question is asking for. That way you know that when you solve your equation, you actually have what the question was asking for. And then the E is for equation, so you're going to use your variable to write an equation. Or sometimes you need to write an inequality based on what the question is asking for. And then what do you do with an equation? But you work on it. So you want to show your work. W is for work. Show the work to solve your equation. And then you're going to get an answer to your equation. So A is for answer. But that answer isn't necessarily going to answer the question that the problem is asking for. So we have S, which is sentence or solution, and you actually need to write your answer as a sentence or as a solution with appropriate labels according to whatever the problem is asking for. So write your answer as a sentence, and what really means is use proper labels to actually answer what the question is asking for. For example, maybe the answer was 5, but you need to say that it is $5. All right, so let's try our first problem. It says, example 1, write an equation using VUAS for each problem and solve. So Jennifer bought 5 pounds of apples for $3.45. What was the price per pound? So for V, I'm just going to use P, and I'm going to define it as price per pound because that's what the problem is asking for. And then as an equation, I can write 5 pounds equaled $3.45 because that's what the problem tells me. So I got my equation from the actual problem. And then I'm going to show work on my equation. So I want to solve for P. I'm going to divide both sides by 5. And then as an answer, I get P equals 0.69. So now I want to actually express that as a sentence that answers the question that was being asked. So I might say the apples are, and 0.69, you're talking about dollars, so 69 cents, or if you want to put it in dollar sign, you can put it $0.69 per pound, and that answers what the question was asking. Okay, so let's try the next one. I want to go ahead and set up my V. After Henry withdrew, that means to take out, $350 from his account, he had $1,150 left. How much money was in his account before the withdrawal? So I'm just going to make my variable M, and I'm going to define that as the money in the account, but I want to be more specific than just the money in the account. Like, is that the money in the account before he took it out or after he took it out? So I'm going to say that's the money in his account before withdrawal, meaning that's the money that he had in there before he took it out. Okay, so my equation would be the money that he has in his account before he withdrew it, and then he took out $350 and he was left with $1,150. So then I want to show work on my equation to solve for M. I'm going to add 350 to both sides of the equation. And then the answer I get for M is 1,500. So now I want to go ahead and make sure I'm answering the question and say he had $1,500 in his account. All right, the next one might be helpful to draw a picture to actually understand what they're asking about. So I'm going to set up my V because I know I have to start with a variable. A road that is 8.5 m, which is meters, is to be extended to 10.6 meters wide. What is the width of the new paving? So it's kind of like this situation. It looks like they have a road. Okay, so here's my little road. And right now, this road is, so from here to here is 8.5 meters wide. And then they're going to extend the width of it. And the new width is going to be 10.6. So what it's asking for is, how wide is this new paving? So I'm just going to let W represent the width of the new paving, because that's what the question is asking for. And I'm going to write an equation using my variable. So the present road is 8.5 plus the new width of my new paving is going to end up being 10.6. And then I want to show work on my equation. So I'm going to subtract 8.5 from both sides. And then my answer I get for W is W equals 2.1. And then we'll make sure that we can actually write the answer to the actual question that's being asked. So the width of new paving is 2.1 meters. So we'll make sure we put a label on it. All right, next one. In the 7th grade, 86 students made the honor roll. This number, this 86, is 2/5 of the entire class. How many students are in the 7th grade? So set up my variable. I'm going to let N represent the number of total 7th grade students, because that is what the question is asking for. For my equation, I'm just going to write what the problem is telling me. It said that 86 students that made the honor roll equals 2/5 of the entire class. So of, when you see that, that really means to multiply. So whenever you see of in a word problem, it means to multiply. 86 is 2/5 of the total number. So I'm going to show my work. So to work on that equation, I can solve for n by multiplying both sides of the equation by the reciprocal of the coefficient. So I'm going to multiply both sides by 5/2. And then the answer I get is n equals 215. So my solution, there are 215 students total. Okay, example 1E. A 25-foot floor building is 105 meters tall. What is the height of each floor if they are all of equal length? That's pretty important. So I'm going to set up my V. I'm going to just let h equal the height of each floor. And notice that I'm not just choosing a variable, but I'm actually defining it, like writing what it represents. So I'm going to set up my equation. I have 25 of those floors, so 25 heights equals a total of 105. Show some work, right? So I need to divide both sides by 25. And then for an answer, I get 4.2. So my solution is each floor is 4.2 meters high. All right, so that's VUAS for the first couple problems. All right, for the second page, we have a 150-liter tank in a chemical factory can be filled by a pipe in 60 seconds. So in this case, L represents liters, S represents seconds. At how many liters per second does the liquid enter the tank? So I want to make sure I define my variable. I'm just going to use X as liters per second. I can't just say liters because what does that mean? Liters total or what? I want to make sure that I define it to what the question is asking. So now I'm going to write my equation. I know that I have 60 seconds times liters per second is the total of 150 liters. Show some work. I'm going to divide both sides by 60. And then my answer I get is X equals 5/2. So it would sound kind of strange to say that it enters at 5/2 liters per second. So when I write my solution, I'm just going to make the label more appropriate, or I'm going to change this to a decimal. So I'm going to say the liquid enters at 2.5, or I could say 2.5 liters per second. All right, example G. 3/4 of, there's that word of, all library books in a school library are nonfiction. There are 360 nonfiction books. How many books are in the school library altogether? So I'm going to let F represent my number of total books. Like I might have used B for books, but sometimes the B looks like a 6, and I don't want to get confused. So I'm going to write an equation. I know that 3/4 of all the library books, so 3/4 of times F is 3/4 of them, of all of the books are nonfiction. So and I know that there's 360 nonfiction books. Okay, so I'm going to show my work. So on this equation, to solve for F, I know I can multiply by the reciprocal, 4/3. And then for an answer, I get F equals 480. So my solution, there are 480 books total. All right, example H. After using 2/3 of a bag of fertilizer on his garden, Kent gave 8 pounds to a neighbor. If Kent had 42 pounds left, how much had been in the full bag? I think sometimes it's helpful to draw a picture when you have a situation like this. So I'm just going to picture that he has this full bag, Okay.